We'll use normal node structure. So give heading BST implementation. BST implementation. So we'll normally use a C function. So first of all, I'll draw here a tree, so that will be easy for us, to understand the operations. So let's say here I'm considering this particular tree. How can I say? Okay, I'll take simple tree to make it very clear to understand. Okay. And there are certain values. Say 15, 10, 12, 9, 20, 17, 25. Okay, so let us assume this is simple BST and we need to construct. This is the root. Inside these are its left and right childs. Index are given over here. Okay, so we'll go for first of all the implementation part. So we'll start from the scratch. Okay, so first of all, we'll include a main function. Before that, right, standard input output dot h. Now I'll declare a node. So we have seen a node. So we'll put here a type def node struct node. Okay, so inside that there are three things. First thing is a data, as we have seen so many times now, node definition. There is a left pointer and the right child pointer. Link is there. This is okay. Now let's go for the main function. So in main function, first of all I'll create empty root. So in main function, I'll create a root and we can initialize that root to null. So this is a root node star pointer. So when I am creating a root, we initialize it as a null. So the root will get created and null I'll just write here as 0. Okay, and this is a root. Okay, so I'm creating root pointer. Then I want to go for the insert function. Okay, so what we can do here, simply we can write root is equal to insert root comma 15. So I want to insert here first node 15 I want to insert. Okay, so now we supposed to write insert function for that. So insert function is returning basically a node pointer. So we can declare here the insert function also. So we can declare here node insert. We're passing a root also. So you can say here node star root and int. Okay, that's how we can go for this. Now what I'll do, I'll write a insert function over here. Okay, so I remove this particular tree now. So we'll write here insert function node insert. Okay, and then in insert function we are taking a root, so we write here node root and then int data. Okay, so now what we supposed to do, if root is null, we supposed to create a node. So if first step, if root is null, then you can write capital null here. So if root is null, then what we supposed to do, we supposed to create a new root. So root is equal to, you can write here a new root function or new node function for creating a new node, and you can pass the data to new node. So this will create a new node and will give some address over here. Okay, so I'll write here a new node function. So here you can say node star new node int data. Okay, and then here you can say node star temp, and we can say temp is equal to node star malloc size of node. Okay, and then here we can fill temp of data is equal to data, and then make its left and right pointer as null. Temp of right is equal to temp of left is equal to null. Okay, and then here we supposed to return the temp. Okay, so I'll write here because of there is no space for me, so we can say return temp after this, and the functions completes over here. Okay, so here you need to add one more function above main, node star new node, for creating a new node, and then we are just simply passing an integer data. Okay, so this will create a new node. So automatically, let's say new node is created here, and it will return the address of new node. Let's say data is 15, so I will be inserting here 15. Its left is null, right is null, and let's say its address is 200. Okay, so this will return here 200 to the root. Okay, and here instead of 0 now it will have 200, making point out to this. Okay, so this is how we have created the first node. Now if root is not null, so let's say next I am supposed to insert now. So here this root is new node, and this will return a root to the main function, right? So this is going to return a root to the main function. Okay, so here this root is actually 200. This root is 200, but now this will return now 200 to the main function. This will write 200. Now if root is not null, so what things will happen here? I'll just remove this part. It's just about creation of a new node. So if that is else if that means if root is not null, there is some data in the root, then we will compare. If data is less than or equal to root of data, then what we'll do, we will recursively call for the same function, and then we supposed to go to the left part of the root. So what we'll do here, then root of left is equal to insert. We'll call again same function, insert root of left comma data. So we are going for the left part of the tree. Okay, that's what we did. We'll see actually in detail. Now if data is not smaller, then data is greater than the root. So what we'll do then, else we are going to the right part. Okay, so what we'll do here, root of right is equal to insert into right part passing a data. This is a recursive call we are making here. We're gonna see these in detail, and then once we did with this, simply we'll say here return root. Okay, so now let's see how it works. So I'll remove this part from main. Okay. So initially we have inserted 15. Right. So with the value as here 200, this address is 200. We named it as root. Right, and the value here was 15. So initially this was null. Now next time we passed here insert, let's say 10. So here when we passed here 10, the root was not null. Root is 200 because you have passed here root as, from main we passed here root as 200 and the data is 10. So from main we have made a call for insert 210. Right. Now this root is not null, so we'll come here else if part. What is the root arrow data here? Root arrow data is 15. 200 arrow 15 or 200 arrow data is 15, and actually here data is 10. So 15 is smaller than 10. This condition becomes true. We'll go to root arrow left. So here now 200 arrow left. So 200 arrow left is null. So then we are calling for here 200 arrow left is equal to, we are calling for what? Insert. Now what is the 200 arrow left here? 200 arrow left is null. So we are just, I'll call it as 0 and data is 10. Okay. So this will give call to insert 0, 10. So we'll come here with the root as null and data as 10. So since now root is null over here, what we'll do, it will create a new node. Okay. So let's say this is creating something, a new node with address as, we'll give address something 150. Okay. So this is created a new node with address as 150 over here. Okay, and there we have seen that in new node creation we have inserted data 10 over here. Right, now try to understand, this root is basically local over here. This is not a global variable. This root is local. Now then this if is executed and will come here at the return root. So now this root here is 150. this will return 150. That means this insert 0, 10 will return 150 into 200 of left. So 200 of left, it will get stored here as 150 in the left part of 200. So this 150 will get stored here, and this link is created. Right? Now it has a call for main. So once we finish with this root arrow left equal to insert this 200 arrow left. So at this point over here, the root is 200 and then return root. So now this will return 200 to main function. Okay, and that's how we add here the next value 10. Okay, now let's look at adding one more value. Let's say now I want to insert here 30. Okay, so let's say next thing is about insert 30. Insert 13. Okay, so if I want to insert 13, what I'll do from main, I will give call for insert function with passing here insert a root. So root is 200 and data is 13. Okay, so this is the first call. Now here a root is 200, right, at this point. Now next thing, second thing is it will come here, else if data. So data is 13 and the root arrow data. So root is 200. So what is the 200 arrow data here? 200 arrow data is 15. So now this data is smaller than 13, yes. So what it will do? Root arrow left equal to. So this will give a call to the next function. So this will give call to root arrow left. Root is 200. 200 arrow left is equal to, this will give call to the insert function. Insert. Now root arrow left. So root arrow left is 150. So insert 150, 13. So again we'll come into the insert function now here, where root is now 150 and data is 13. Again it will compare data with 150 ka data. So data is 13, 150 arrow data is 10. So 13 is not smaller than 10. Then this will come at this particular else loop. Then it will compare. Here actually this is greater, so by default we will go into else loop, and this will give call to the another insert function over here, recursive call. So that is the third call here, and in the third call what we are doing here, we are making here, now root is 150, so 150 arrow right is equal to, what we are doing here, insert 150 arrow right. Now here 150 arrow right is null, so we are passing here root as null and the data is 13. Okay, so now look at here very carefully. So when it will give insert 0, 13, so this is insert here. So this is insert 0, I rewrite it once again clearly so we can understand it better way. It's very important concept. So here we are calling from 150 of right. This is about 200 of left. We are calling here 150 of right is equal to, it is giving call to insert. Now root is null and data is 30. Again we'll come into the insert function with root as null and data is 30. So since root is null, it will create a new node. So we have seen new node function. So this will create a new node. In the new node, this will basically enter a data as 13 over here. Let's say its address is 100. Right? So now this will return this 100, this will create here new node of data, and from new node we getting the root as 100, right? So here once we execute this if loop, this will return root. So root is currently what? 100. So this will return 100 over here. Okay, and here, sorry, not here, this is 0 comma 13, right? So this call is from insert 0 comma 13. So insert 0 comma 13 will return root as 100 over here, and this is 150 arrow right. So 150 arrow right is 100, so this will get joined with the right part. Okay, now this has a call from this insert function, right? So this insert function returns something at 200 arrow left, and that is root, correct? So here we are joined 150 arrow right is equal to 100, that we are joined here. Now this function will return root and this call will get terminated. So at this call here the root is 150 and this will return 150 over here, that is 200 arrow left is equal to 150. Okay, now again this call will finish after returning the root as 150. Now point comes here, return the next root 200. So here we have finished root arrow left, that is 200 arrow left equal to 150, that join at 150, and then we'll return root. So at this point root is 200, and here this is actually call from main function, and which will return again to main function root is 200, and finally after inserting 13 we'll get the tree like this. Okay, so this is about the recursive insertion function in the BST. Okay, so next class now we will see the deletion and search operation and display operation in the BST.